Okay, since we ended up with a snow day, I am going to be presenting through this short little video some of the key points I wanted to underscore and address as sort of a summary and review as you finish up studying for exam number 1 in the course. Okay, so last week, the week 5 agenda included reviewing the project number 1 as well as beginning to review some of the content for exam number 1, but this week in this short video I'm just going to be focusing on 2 of the characteristics that we have yet to sort of summarize and cover related to quality assessment items, and that has to do with evidence of validity and absence of bias. So and again, just to remind you, quality assessments they're reliable, they're valid, and they are lacking, or their bias in them are minimized. And some of the tools we use to help determine estimates of reliability or evidence of validity or whether something is biased or not are actual sort of statistical measures. And in order to use statistics on a population sample for estimating reliability or determining validity, we need to first of all know what kind of data types you're dealing with, and then use some of the basic calculations to provide measures of central tendency, variability, and relationship. And those mathematical concepts were some of the things that were also sort of summarized and addressed in last week's presentation and are included in the notes as well. But this week we are going to review probably the most important characteristic of any assessment, and that is whether or not there's any evidence that that assessment is valid. And by valid, we are referring to whether or not it measures what you want it to measure. So again, as a review from last week, reliability asks, do the same methods yield the same assessment results? It's an important characteristic of a good assessment. And validity asks, does the assessment measure what it purports to measure? That's a really, really important concept to consider, and that's what this summary overview is going to address. Okay, there are 3 common ways that you try and determine as an assessment developer. There are 3 ways you try to determine whether or not your assessment is actually measuring what you want it to. And they are content validity, construct validity, and criterion validity. So let's look at the first one, content validity, and that is the extent to which your assessment items and procedures adequately represent the content of the curricular aim being measured. In other words, by the way, that's taken out of the course text. In other words, is the content in the assessment, is it accurate? Probably. Oh, I'm going in the wrong direction. Let's go the right direction. Okay. Criterion validity is one way that the validity of SAT scores have been established is by looking at the relationship between SAT scores and college success in the way that you might define college success: better grades and actually completing college. And there is a direct positive relationship between how well you do on the SAT score and your grades and your whether or not you complete college or not. That doesn't mean that it's that way for everybody. It just means that there's a general trend, and so that's evident that the SAT's assessment has some measure of criterion validity. Okay, so here's a quick little practice item for you. You've been given 3 different ways that you can establish or try to establish evidence of validity. So here it is. Evaluators test a new survey instrument designed to measure levels of test anxiety. And they do that by administering it to students who have self-indicated that they possess either very high or very low levels of anxiety related to testing. So you then take the survey scores that they get on your test anxiety survey and you correlate them with their predetermined levels of anxiety, whether they self-report as being very high or very low. And you correlate that. And what you hope is that the levels of test anxiety reported on your instrument correlate positively with higher levels of self-reported anxiety regarding test anxiety. So what evidence type of validity is being calculated in that instance? And I hope that you are thinking that it would be criterion validity, because we had just that reflects something that we had just talked about there. It wouldn't be you're not trying to measure whether or not anxiety itself, the construct, the items are and the content of them are relate to something that experts would say is anxiousness or anxiety. That might be content validity. And construct validity would be would not necessarily be being measured with this type of situation. Although again, criterion validity is a type of construct validity as well. Okay, and again, the course text has some information about this if you want to learn more. Just a quick reminder, something that is mentioned and discussed in the course text is that you can't say that an instrument is valid unless it is reliable. But an instrument could be very reliable but not be valid at all. And so we have 3 graphics on the screen that are used to illustrate that idea. For example, if you look at the target on the right, you know, the responses or the where performance isn't in the middle of the target where you're measuring what you want to measure, but you give that instrument consistently to people and they answer consistently. They answer the same way the 10th time they take it than they did the first time. That means it's reliable, but it doesn't necessarily measure what you want it to measure. So it's an important consideration to have. Now, before we finish out with bias, I wanted to talk a little bit, because this is one of the objectives, I wanted to talk a little bit about something called threats to validity. And the reason why I want to address this is because this is an important consideration when you're learning more about educational research. And there is a lot of overlap between good assessment practices and good research practices. And oftentimes in assessment, if you want to try to measure some evidence of validity for your assessment items, then you might go through some procedures like an intervention procedure to measure whether or not your instrument is valid, or whether there's evidence that it's valid. And you might use the same procedures to research the effectiveness of your intervention in the first place. You know, but sometimes you give an assessment to a sample of a population, and then you have an intervention, and then you give the assessment again, and there are reasons why your results may actually not be indicative of validity or evidence of validity, or it might look like it is, but it isn't. And those are threats to the actual validity, particularly when you're trying to establish construct or criterion validity. So I have on the screen a picture of a young person smoking, and let's just say for the sake of me introducing some of these threats to trying to validate an instrument, that you have an instrument that is designed to measure attitudes about smoking, and you have an intervention that you're fairly certain, at least you hope, will have an impact on teenage attitudes towards smoking. So you have this instrument and you want to establish some evidence that it's valid, that it really does measure genuine attitudes about smoking. So and so maybe you do an intervention study where you give it to a group of learners or of teenagers, and they score at a certain level on it, and then they have an intervention, an anti-smoking intervention, and you give it to them again, and you would anticipate that if it's a good instrument and the intervention is good, that they would score higher on positive attitudes about not smoking, or conversely score lower on positive attitudes about smoking, you know. So there is a threat, though, to whether or not the results you get in your intervention study would actually be valid or not. So one of them is called selection, and that's where you have an inequality of comparison groups due to pre-treatment differences. So for example, you might end up with a group that you pre-test using your instrument, and they already have that group in general already has a really strong attitude about smoking, versus the post-test that doesn't. A good example of this would be if you gave the instrument to students in a 0 period class, and they scored at a certain level, and then at the end of and then everybody in the school maybe gets an intervention study, and then you don't test the same students, but you might test students who aren't in your 0 period, and they have very different scores. The problem with that is oftentimes kids who end up in 0 period are there because they're higher achievers, and they have other AP classes that they have to meet at other times in the day. Their schedule isn't as flexible, and so they're actually taking more classes, and they might reflect a different population. So you can overcome threats to selection validity by randomly assigning the members of your study, by doing some kind of pre-test in advance, to try to figure out whether or not they are at a particular, your population is at a particular level. Or you can just block your subjects by a particular measure initially. Maybe you want to block your subjects by whether or not they are already indicate that they currently smoke, or that they have smoked, something like that. Anyway, so selection of subjects could represent a threat to validity. History can certainly reflect a threat to the validity of trying to test an instrument. History, particularly in an area like smoking and attitudes, history is where some event happens that during the treatment phase, in addition to what you're testing, that really has a positive impact. For example, if you're trying to, if you have a study that that you think an intervention that you think would have a positive impact on a healthier attitude towards smoking, but during that time a movie comes out, a very popular movie comes out for teenagers, and some of the main characters in them are smokers, and they're modeling that behavior, then that might have a much more profound impact on attitudes regarding smoking than any kind of intervention. So you might see your instrument not operate about attitudes, not operating the way you thought it would, but in reality it could end up being operating exactly how you had hoped, because it is being responsive to attitudes about smoking. You just weren't sure what the interventions were that were having an impact on that. So that's history. Again, the way you try to minimize it is making sure that only planned variations occur between the groups, and be cognizant of historical things and record any things that might affect performance and attitudes. Statistical regression is really actually a fairly simple phenomenon that occurs, and that's just the tendency of groups or of individuals within groups with extreme scores on any measure to score closer to the mean the second time that they take it. And so that can happen. That happens consistently. It's just a characteristic of the retest reliability. And again, one good way to counter this is to use equivalent control or comparison groups that also have those extreme scores, so that you know that everybody's regressing. Mortality is also an issue. That's a differential loss of subjects from the comparison groups known as attrition. For example, if you were going to take attitudes about smoking at the beginning of the year and attitudes about smoking at the end of the year among teenagers, and let's say that there were some interventions going on in between, and you end up with results at the end of the year that may actually be skewed because you have subjects who drop out of the study. And it's possible, I'm not saying that it is, but it's possible that the likelihood of somebody who drops out of school, the probability that they have an attitude about smoking that's maybe different than the average attitudes, that's a very real possibility. So mortality is an important variable, to consider. And a way to help combat this, again, is to only use data from subjects who are in the whole thing from start to finish, and also check to see if there's much difference in groups and in terms of numbers, in participants. You can also interview some subjects who did drop out and find out why they dropped out of school, maybe, and then get some characteristics of their behavior that you might be able to tie to the variables that you're studying. Testing is another threat to validity, and that's simply that anytime somebody retakes a test, there's going to be some level of difference in how they interpret the items and how they respond. And so sometimes the best thing you could do is not have a pretest when you want to minimize the amount of testing, depending on what variables you're actually trying to establish validity on. Or you can pretest, get the general attitudes for people outside of the intervention study. You can also use alternate forms, possibly. That wouldn't be a bad thing to do, say, with a smoking attitude survey. Alternate forms maybe just being that everything is presented in a different order and in a different, perhaps, format the second time. You can also just use item sampling on the pretest, so that only a few of the items are actually responded to, going in the pre-intervention group. And if you have enough subjects involved, you can piece together a whole profile of responses that way. And then there's, of course, maturation, which is simply subjects change during the course of an intervention or during the course of an instructional experience. And attitudes from teenagers about smoking might just naturally change because they're getting older and they're getting and it could go either way in terms of attitudes. You can help identify this and mitigate it in some way by comparing the results of your intervention study to control groups of similar age subjects who didn't get any intervention. Minimizing the amount of time between testing and retesting could be important as well. There's also instrumentation is also provides threats to validity, and that's simply that the instrument itself, or how it was implemented at different times, might have caused differences in how people respond to the items. And again, not pre-testing, ensuring that all the people who are implementing the survey have training, and that the test itself hasn't changed from start to finish. Oops, here we go again. All right, that's and that was instrumentation. Again, there's a nice summary table of these in the course notes, so take a look at that. The last thing I wanted to review with you was the idea that quality assessments are free from bias. And bias is offending or unfairly penalizing any group of students on the basis of their personal characteristics, such as their gender, ethnicity, socioeconomic status, race, or other variables that might affect the way they communicate, such as having certain learning disabilities, language issues, or even their writing preparations. It's important to note that, and I included that in red on this screen, because oftentimes assessments make the assumption that everybody who's responding is operating at a similar level of communication abilities when it comes to writing. or speaking or communicating, or formulating their ideas. And that's just an erroneous assumption to make. And again, biased items can lead to distortions in identifying how well individual students can actually perform on items designed to measure the skills that you want to measure. So bias is a super important thing to be cognizant, to be aware of. And one of the things that we were asking you to do is for this class is identify where given assessment items might be biased, and suggest strategies for improving them. So some of the categories of bias that I present in the course notes has to do with we have content bias, and that is, does the item itself have content that might be unfamiliar to the people taking the test? When you do word problems or analogies, you might be using terminology that is unfamiliar by some members of the population. And does the content reflect some information or skills that they might not be expected of them within the background of everybody there? So it's important to make sure that the content represents something that you have some assurance all your students are familiar with. Language bias, again, does the assessment item contain words that have different or unfamiliar meanings? Is it free of difficult vocabulary? That's something that you need to be very aware of. Is it free of language that might be distracting? Pronouns, the use of he consistently might be distracting for people who identify with a pronoun of she. It's important just to be aware of that and to use variability throughout your item building. And of course, fairness and stereotyping. You don't want people to you don't want learners to have a visceral reaction to the information, so much so that it could hinder actually just responding to the assessment items. And some of the characteristics in stereotyping include how you represent members of the population. You might have a math item where somebody who is is in a word problem, is doing something that it seems like they're not thinking very well, or they're not using their reasoning, and the way and that person might be represented as a particular ethnicity, or by gender, or by age, or by position, and that might be offensive to some people. So it's important to do that, to be aware of that, and trying to find an equal balance of representation in terms of the what ethnic groups are being represented, what activities are being described, and that kind of thing. So fairness and stereotyping, and again, just walk through the notes and regard them as a collection of strategies you might use to help improve items. And we have a couple of simple examples. These are also presented in the course notes. Somebody in a 7th grade language or arts program might be given an assessment item that asks them to underline all the proper nouns in a sentence. But by the way, this was an actual test item I got from a student in this class a few years ago anyway. And it must have been an older teacher who designed this one. But some people saying the failed policies of President Jimmy Carter and tying that to what's wrong with Democrats. Again, if you have a student has strong feelings politically, they might take such offense at the statement that they can't get to the skill you're trying to measure. Another example of bias that's not as obvious is one, again, actually taken from an assessment that I got from a student. Write a poem that describes the journey a drop of blood takes as it travels through the human body. Granted, I think it's a great idea if you really do want students to learn what the different parts of the human heart are. But asking them to write poetry is asking them to communicate in a way that some of them may not have the prerequisites for, unless, of course, the biology teacher spent a good long time helping students learn how to write poetry, which I highly doubt that they did. So there's an obvious bias there against people who don't have as much writing experience. So that's not a great assessment item for that reason. The last thing I want to talk about is that if you want to try to use empirical methods to identify and correct biases, then you're gonna really run into some problems, because in order to do that, to use empirical methods, you have to examine statistically the response patterns of the different people taking the assessment, completing the assessment, based on the characteristics that you might want to be examining regarding bias. So in this example here, you have these you have participants who complete an assessment, and they are identified by their gender, ethnicity, their religious preference or their religious identity, as well as their socioeconomic status. So they profile themselves using those characteristics, and then they respond to different items on an exam. So here we have item 1 is what is being represented in this little table. And these are the 1, 2, 3, 4, 5. These are the 6 students who responded. So the question is does this item appear to be biased in terms of responses based on some of the factors that you don't want it to be biased against? So here we have that the first person responded, the female responded, they picked item A. And in order to do a statistical calculation to find out whether or not poor Baptists who identify with ethnicity number 1, whatever that is on the instrument, as well as gender, females, in order to determine whether or not they pick item A more regularly or less regularly than any other group, you might need to have data from 200 of them. So think about how many total subjects you would need in order to determine whether or not more poor Baptist females of ethnicity 1 respond differently and select item A differently. That requires thousands and thousands of subjects, and that would be difficult, if not impossible, to do for most sort of teacher-made assessments. But if you think about it, that's not difficult at all to do on assessment items that are implemented at a state or national level, which is one of the reasons why items that are designed and implemented like Virginia SOL tests or SAT tests, things that are implemented nationally, they usually end up over the course of being implemented turning into a collection of items where there is a lot of evidence of validity and very minimal bias. Of course, you can go online and read research papers about some of the small ways in which they are being accused of bias from different perspectives. But again, it's not that difficult to run statistical tests on the data to determine whether or not there actually is something anomalous about a subpopulation of people responding a particular way on a particular item. So, and it happens all the time, and items get kicked out all the time in those large-scale, high-stakes implementations. So, but again, that's why you can't do it with any amount of success if you're just doing it in a teacher-made test. The bottom line, of course, in terms of trying to minimize bias, isn't to try to collect data and correlate characteristics to see if there's evidence of bias. It's really just to use common sense. Look at some normal ways in which things could be biased without even knowing, and just try to use common sense in editing them. And the same could be said for how you go about trying to establish evidence of validity across all 3 of the types that we are represented: the content validity, the construct validity, and the criterion validity. And that just about does it for the information that needed to succeed with exam number 1. It's time now for you to go and take the practice exam. Respond to the items, and if you have any questions about the questions in the practice test, or about your responses, or about the correct responses, just feel free to contact me. You can post it on the blog, or you can email me, and I'm happy to discuss it with you. Okay.